Hello everyone, welcome back. Hope you are enjoying your day and you have enjoyed previous lectures on this topic, algorithms. In this lecture, I would be discussing about insertion sort. This is a very basic algorithm to give some more understanding about algorithms and try to set up a very basic understanding about this subject. So let's talk about insertion sort. Excuse me, my throat is bad today. What do we mean by insertion sort? As the name says, that we're going to be doing some sort of insertion in or insertion out. For example, with the playing cards, you guys might be familiar or may not be, but for now, let's say you have some cards in your hand which are numbered from 1 to 6 and in an unsorted way, and I ask you to sort them out. So what you're gonna do, you may do quickly, or you can scan these cards numbers and quickly figure it out that number 5 card is supposed to be beside number 6 in between number 4 and 6 card. So you take number 5 card out from this position and insert this card in between 4 and 6. Same thing you do with the cards which have other numbers. Let's say for example number 1. So you can quickly scan and find out that okay, number 1 is the smallest number, so I should take this card out and I should insert this card at the very beginning. Same thing you do with the number 3 card. You can quickly find out that number 3 card is bigger than number 2 and less than number 4, so it should be in between 2 and 4. So take number 3 card out and insert in between 2 and 4. And finally, you get the sorted cards sequence in your hand 1, 2, 3, 4, 5, 6. But in this way, this was a very ad hoc manner of sorting it, but in some way you would be doing insertion sort. But let's try to formalize this method in a way so that a computer can understand and we can develop an algorithm for insertion sort. What inputs do we have? Let's say we have a sequence of n numbers, a1, a2 up to an, or for example 15, 12, 14, 16, 11, 13, unsorted sequence. What output do we need? We need a sorted sequence. For example, a tick, a2 tick, a tick n, such that a1 tick is less than a2 tick, is less than tick 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 an, or 11, 12, 13, 14, 15, 16. So let's see what we can do. We can store the unsorted numbers in an array. Those who are not familiar with an array or data structures, I would recommend you to watch my another video which I did on data structures to give you basic understanding about arrays. But for now here, let's assume that you have already watched that video or you have some basic understanding about data structures or array. So we store these numbers in an array. Say at position number 1 it's 15, position number 2 12, position number 3 14, position number 4 16, position number 5 11, position number 6 13 are stored. And the idea here is to find the correct position of a particular value. So we start from position number 2 because we already have one number at position number 15. So it makes more sense to start position number 2. And here another convention is that the dark colored boxes and the light colored boxes. So dark colored boxes means that we need to find the position which is stored in dark square box. And light color boxes means that we keep on checking the numbers or values which are stored in the light color boxes, and if we find we need to move this number which is stored in light colored boxes, we move it to the next square or the next position. So let's see what we can do. We are at step first. We start with position 2 and we compare the number 12 with number 15. So we find that okay, number 12 is smaller than number 15. So what we do? We take the number 15 out from position number 1 and insert in position number 2, or in a picture position number 2. Now we see there is no more element to compare we have here, so we store 12 at position number 1 and we end this step or inner loop. Now we move on to the second step. We go back. At this step 2, our array would look like this: 12, 15, and rest of the numbers unchanged. Now we are at position number 3. We colored this box dark and the number stored is 14, and we do the same operation what we did in step A. We compare number 14 with the number stored in a previous position, that is 2 with 15, and 14 is less than 15. So what we do? We move number 15 to the next position, that is position number 3. So the 15 goes to position number 3 and 14 is at position number 2. Now we move to the next number backward direction. So we then find out that okay, we have one more position to go in backward direction. So we compare what number is stored at position number 1 with the number 14. We find that okay, 14 is bigger than the number which is stored at 12. So at this step we found the position of the 14. So we insert 14 at position number 2. So the position number 2 contains 14 and position number 3 contains 15, and we end our inner loop. Now we move to the step 3, step C. We see our array would look like this: 12, 14, 15, 16, 11, 13. And now we take the number which is stored at the position number 4, because we have already did the operation up to position number, or we executed these steps up to position number 3. So at position number 4, 16 is stored. We do the same operation. We check number 16 with the previous position, and we find that okay, now 16 is bigger than 15. So we do not have to move number 15 to right or to position number 4, and we end this loop, inner loop, and 16 remains at position number 4. Now we move on to the fourth step. At fourth step, our array would look like 12, 14, 15, 16, 11, 13. And now we are at position number 5 in our array, and we are trying to find the location of the number stored at position number 5, that is 11. Okay, so now what we do? Same thing. We compare number 11 with the 16. And now 11 is smaller than 16. So we move number 16 to right side. That is from position number 4 to position number 5. Good, we moved it. And then now we compare number 11 with the next position going backwards, which is position number 3. So we compare number 11 with number 15, and we find that 11 is less than 15. So what we do? We do the same thing. We move number 15 to the next position. Number 15 goes to position number 4. And we keep on doing the same operation till we find the end of the array, or till we find any number which is less than 11. So now we compare 11 with the number 14, which is at position number 2, and we find the same thing. 11 is less than 14, so we move number 14 to the next location or next position, that is 3. 14 goes to number 3 position, and now we compare number 11 with the position number 1. And same thing, number 12 is bigger than number 11, so number 12 goes to position number 2. And now what? We have no more room left to go backwards. Number 1 is the position for number 11, so we store number 11 at position number 1. Isn't it interesting? I hope you are with me at this step. Great. Now let's go to the step number 5. At step number 5, our array looks like this: 11, 12, 14, 15, 16, 13. And now we are at the final position in our array, that is 6. At our position number 6, number 13 is stored. We do the same operation, compare 13 with the 16, previous position. 16 is bigger than 13, move 16 to the next position, that is 6. And then we compare 13 with the 15, and we find 13 is less than 15, so we do the same operation, move 15 to the next position. So move 15 from 4th to 5th. Then we keep on doing, we do the same thing, we find that 14 is bigger than 13, move 14 to the next position, that is 4. And now we do the same operation with the position number 2. Now here is the interesting thing. At position number 2, number stored is 12, and our number in the dark box which we had was 13. Now 13 is bigger than 12, so we stop our inner loop here. So we found the position, correct position for number 13, which is position number 3. So we store 13 at position number 3. Good. So now at this step our array is sorted. Final step is nothing but a sorted array. 11, 12, 13, 14, 15, 16. Good. Great, isn't it very simple? Very interesting. Hope you have enjoyed it. Now let's try to develop an algorithm out of these sequences. The algorithm, we can write a for loop, and we start the first step. Remember, we started from the position number 2, so we start our outer loop from 2, and it goes all the way up to the length of the array. J is the looping variable, outer looping variable. Now we pick up the value which is stored at AJ and put it in a variable called dark square value. And now after we picked up this value, we are trying to insert this value in a sorted array or sorted sequence, which is from A1 up to J minus 1. Now let's try to define another looping variable, I equal to J minus 1. That is a inner looping variable, or let's say, I shouldn't say looping variable, I should say just a simple variable which will act one of the condition in our next while loop here. So while I is greater than 0. Remember, in this step we are moving backwards, so our I should be decrementing. So if our I is greater than 0 means we haven't reached the end yet. And the second condition also, if AI means the value which is stored at the previous location is greater than dark square value, then we move the value which is stored at AI, means the previous position, to the position where the dark colored square value was stored. And if any of this condition is not true, then we come out of the while loop. So we store the value which was stored in AI, stored at the location where the dark squared value was stored, and we decrement I, our looping variable or a simple variable. And after finishing this while loop, we have no more, we came up to end and final location. We store the value, dark colored square value, in AI plus 1, and our for loop. After finishing up our for loop sequence, we will get a sorted array. This might look like a bit confusing, but trust me. Write down these step by step, take a pen and paper and do as you think computer would do. So write down individual steps, how the loop is executing for this small example, and you will understand it much better. I hope you have enjoyed this lecture about insertion sort. Do not forget to subscribe LEPROFESSEUR YouTube channel. If you are facing difficulties or if I can help you, you can arrange private tuitions or private lessons. You can send me an email at hr@leprofesseur.org. And thank you for watching this video. Thank you for subscribing. Hope to see you again. Have a wonderful day.